Good morning, Abyssers.
Birthday to you. Happy birthday to you. Happy birthday, dear Scrooger. Happy birthday to you.
Well, thank you. That wasn't the song I was going to start out with. In case you're worried.
I hope that was live.
Oh, shoot it. It was on mute. No, I'm just kidding. Which is 90% of the time. All right. Well, thank you very much. Oh, I got to turn the volume. Oh. Can you hear that? You know who this is?
Well, it's all right. Riding around in the breeze. Well, it's all right.
I think they're all dead now. No, one might be still alive. George Harrison. Do you guys know who George Harrison was? George Harrison was one of the Beatles. I'm going to go blank. Who sang Pretty Woman? Roy Orbison. He was on that group. And then the guy who just died of a heart attack a couple of years ago. Yeah, rock and roll guy. I could see him. He's in that group. I'll see if I'll remember it later, Brady. Right now I'm having that moment. So anyway, this is it. This is the last lecture of the year. There is no more after this. So we're going to do a little review because this is all about limits. We started with limits. Oh my God, I got to turn this machine off. And we end up with limits. And this is called Hopital's rule, which if I would have gave you this at the beginning of the year, you go, really? You made us do all this work and I could have just done this? This would have been a lot easier. Okay? So we're going to do a little bit of review here. Is Holland here? How you doing, Holland? You're going to take second Holland Homework Central Thursday?
Yeah.
Okay.
We're doing the lemon quiz today.
Yeah, I don't care. That's between you and Mr. Sievertson. Okay, do you need a lemon? Yeah, I have a lemon. So I do care. Yeah, I don't know what it's been in there for over a week. Well, might be a little growth somewhere. I don't know. I haven't looked at it. I'm getting my picture off of here because
It's not a real lemon.
It's a hybrid. It's not.
Nope. But it
All right.
smells really nice.
So we're going to start with Hannah.
Yeah.
Okay, Hannah? The limit of x as x approaches 2. 2 is correct. Perfect. Okay, Hannah, you could pick the person to do number 2. So how are you going to do this limit? When I plug in, she was able to plug in 2 and get 2.
Yeah.
That was really nice. Can you plug in 2 here?
No.
So I'm going to write the limit as x approaches 2, and what am I going to have instead?
Can I get another hint?
Factor.
Um,
I'll write x minus 2 here, and I'll write nothing else on the bottom. What about on top? Give you a hint. The conjugates, or what I like to call the evil twins.
x minus 2 and x plus 2.
X minus 2, x plus 2. Perfect. And what will happen?
The x minus 2 is the cancel out.
Like that?
Mm-hmm.
Sorry for the black line, and I didn't make it red. Equals then?
4.
4. Okay? So on this function, is 4 a y value?
Yes.
The answer is no.
Or, oh.
Okay? So you're half correct. Okay? Because I can't put 2 in there, can I? So this equation, x plus 2, looks just like this equation, right? Except there's what in this equation?
A hole.
A hole. Not an asymptote, correct? Do you know how algebraically you can distinguish between an asymptote and a hole? I'm reviewing because May 14th we have a test, right?
Yeah, a whole they'll both cancel out, but an asymptote is just undefined in the denominator.
Perfect, perfect. I like how you said that, undefined. All right, who are you going to pick for my favorite number, number 3?
Is there anyone who wants to? Megan?
Megan. What am I supposed to do here? You want me to give you a hint? You want to multiply by a conjugate. So I'm going to put a big dot here where that equal sign is, and I'm going to draw something. You're going to multiply the top and the bottom by something. And it's the conjugate of something.
Is it the conjugate of the top?
Right, because the reason we choose the conjugate of the square root is because when we multiply by the conjugate of the square root, we get rid of the square root on top. Okay, so that conjugate looks like what?
Square root of x plus 2 plus 2.
And their conjugates don't have a middle term, do they? They're a binomial all the time. Okay, so down here I have x plus 2 plus 2. Alrighty, so when I do that, oops, I'm going to write limit here. X approaches 2. Down here I'll have x minus 2, and I'll have the square root of x plus 2 plus 2. I'll put that in parentheses. What will I have on top, Megan?
X plus 2.
What else? Minus something.
X minus 4.
Minus 4. Okay. What is x plus 2 minus 4?
X minus 2.
Which is the same as this x minus 2, right? So I am going to get a red pen because I just can't. I got to wait. I just can't. This is my last time to be able to probably do that. Oops. Terrible pen. Okay. And when this simplifies, what replaces in this numerator? A 1, not a 0, a 1, right? Because I got 1 over 1. So now I'm going to put 2 in here, and on top I'll have 1, and 2 plus 2 is, and the square root of 4 is, and 2 plus 2 is, so my limit is 1/4, right? We're just finding limits. All right. Who are you picking, Megan? Who? Hillary. We're not going to a constant. We're going to infinity. Infinity means I don't care about 0. Okay? So you guys are getting good because you're starting to read my mind, aren't you? That's why I paused. I'm looking at what happens when I go to a billion, a trillion, a Google. Or you know what a Google is?
It's a really big number.
Yeah, it's 10 raised to the 100 power. Or a 1 with 100 zeros behind them. And then, in fact, the Google search engine is really Google misspelled. That was a typo on their part. They didn't catch it because they didn't have spell check back then. Okay. And a Googleplex, do you know what a Googleplex is?
Is that 10 to the 1,000?
It's a Google raised to the Google power.
Oh.
So it's 1 with 100 zeros raised to 1 to 100 zeros. It's mind-boggling, just like infinity is. So how do I do this? Remember?
5, I think.
Yeah, look at the degrees.
They're the same.
They're
So
the same.
Just 1/3.
Where did you get the 1/3? They're called the what?
The coefficients.
What coefficients?
Leading coefficients.
The leading coefficients. Very good. Just by that simple hint, you did very well. Right? Remembering those? I'm going to make it easier than that.
Thank you.
Okay? And so we're going to talk about something called indiscriminate form. Oh, excuse me, thank you. Indeterminate form. People don't know that, but in this class I have autocorrect verbalization. Okay? Like when I make a mistake, people say, you goofed up. This is the correct word to use. So, yeah, indeterminate form. If you look at it, I have things like 0 over 0, infinity over infinity, negative infinity over infinity, or positive infinity over negative infinity, and negative infinity over negative infinity. Those are indeterminate forms. Maya, they're all in fractional form. So to use L'Hopital's rule, it has to be in fractional form. And what you're doing is you're taking the limit. You are not doing the quotient rule. The quotient rule finds the formula for the derivative, which gives you the slope of the tangent line on any point in the function. This is different. You're taking a look and saying, all right, I have this function. It's in rational form. It's either going to be headed towards a constant or it's going to be headed towards infinity. If you take BC Calc, and we're talking about BC Calc, when you are headed towards a number, like we were in these 4 examples, right? They all had numerical limits. These 4 examples, these 4 functions converge on a number. So we say that these functions are convergent. And one way to determine if they're convergent is using L'Hopital's rule. All right? It needs to be in this one of these forms. It does not matter whether it's approaching a single number or if it's approaching infinity. And here's what it says. It says L'Hopital's rule applies only taking the limit of the first group. These are other indeterminate forms, but we're only going to focus on the first group. If you're asked to take the limit of the second group, you somehow must rewrite it in the form of the first group, if you can. We'll get to some examples by that, okay, Jeremiah? All right. So L'Hopital's rule states that if the limit of the numerator, I'm going to call it f of x, as approaches c equals 0, and the limit of the denominator, which I'm going to call g of x, heads 0, or if they head to infinity, where c can be a constant or infinity, you can determine this by taking the derivatives of both functions separately. In other words, this limit is equal to this limit. All right, I'm going to show you how it works. So the first thing I'm going to do is I'm going to take the limit as x approaches 0 of e to the x minus 1. That's the first thing I'm going to do. Why do I choose that, Morgan? It's the top function, isn't it? And when I plug that in, what do I get? 0. Because e to the 0 is 1, 1 minus 1 is 0. Okay? So now I'm going to take the limit of the bottom, Morgan. And the bottom is x, correct? And what is the limit of that function? 0. So I have 0 in the numerator and I have 0 in the denominator. You must show this every time you apply L'Hopital's rule. Because this is true now, I can take the derivative of this. Cameron, what's the derivative of e to the x minus 1? E to the x. So now I'm going to take the limit as x approaches 0 of e to the x. And now I'm going to take the derivative of x. What's the derivative of x? 1. So where did e of the x come from? It's the derivative of e of the x minus 1. What's the derivative? Where did 1 come from? It's the derivative of x. So now I'm going to substitute, or Cameron is, he's going to substitute 0 into here. What do I get when I put 0 in for x here? And so my limit is 1. So what's the limit of this? It's 1. I'm done. This one we did a long, long time ago. Did I do something called the squeeze theorem in here? Did I have two people that are forcing another person in a particular direction? I think I did that, didn't I? Didn't I have Josh and...
No, I think you canceled activity.
Did I cancel that activity?
You were gonna, you picked people.
Because you like the kids.
I picked people for it and then I stopped? Okay, I must have had a brain malfunction. Okay. So Hunter, what I'm going to first do is I'm going to take the limit as x approaches 0 of the sine of x. What's that going to give me? 0. And then I'm going to take the limit as x approaches 0 of x. What does that give me? 0. So now I have both 0 in the numerator and the denominator. By the way, at the AP conference, they told me, make sure your students do that. Otherwise, we won't accept their answer. So I'm going to take the limit. Now I can apply L'Hopital's rule. What does that say? Well, give me the derivative of the sine of x. Give me the derivative of x. Plug in 0. What do you get? 1. The answer to this is 1. Isn't this a nice way to end the year?
Do they
You're
have,
going, yeah, I can do that. Yes, ma'am.
do they have to equal 0 or could they equal any number as
They-
long as they equal the same number?
They either got to both be equal to 0, or they both have to be equal to some type of infinity.
Okay.
Either positive or negative. Okay? It can't be a combination of 0 and infinity. They both have to be they both either got to be 0, or both of them have to be some type of infinity, positive or negative. Okay? Yes, sir.
So taking the limit of the numerator and denominator, you're just doing that to see if it's like indeterminate?
No. Oh, this right here?
Yeah.
I'm doing this to determine that's indeterminate because I have 0 in the numerator and 0 in the denominator. So it looks like this form here, which I got yelled at because you are not allowed to write this. It's like Voldemort. We're not allowed to say it. Okay? Okay? You understand what I mean?
Yeah.
Because that is not an acceptable thing to write in mathematics. So what we do is we write it this way and realize that I have 0 over 0. Does that make sense?
Yeah.
Okay, can I go to the next page?
Yeah.
Okay. So, I'll make this a little bigger. Hunter, pick somebody for me. Nick. Nick, I'm going to take the limit as x approaches 0 of what? E to the x minus 1. And what will I get? 0. And I'm going to take the limit as x approaches 0 of 3x plus x squared. What do I get? 0. Okay? If I did not get that, if I got like 12 and 0, I can't apply the rule. They either both have to be 0 or they both have to be some type of infinity. Does that make sense when I say some type of infinity? All right, so that means now I have what as a limit?
E to the x over 3 plus 2x.
Okay, what will I get if I plug 0 into that?
1/3.
1/3. Who are you going to pick?
Brady.
Brady, I'm going to take the limit as x goes to infinity of e to the x. So I'll put in 1. Then I'll put in 1,000. Then I'll put in 1,000,000. Then I'll put in a goop. Where am I headed? Infinity. Then I'm going to take the limit as x approaches infinity of x. What does that give me? Infinity. So now I can rewrite that as the limit as x approaches infinity of what over what. Now I can apply the rule because I've demonstrated that I have an indiscriminate form. Does everybody follow my reasoning on that? This is my quality control. I just can't randomly use it. I have to demonstrate that I can use it. Okay, what do I get? E to the x over 1. Okay? which is e to the x, correct? What do I get? I get infinity. In other words, a numerical limit does not exist, correct? In other words, this is growing without bound. It kind of makes sense. The growth of e to the x looks like this. Here's what e to the x looks like. Correct? Here's what x looks like. Which one's growing faster? E to the x. So my answer should be e to the x, correct? Because e to the 100th power over 100 is a big number. Yes, sir.
Would they be asking for a numeric value?
Pardon?
Would they be asking for a numeric value, or would you have to leave that?
I'm just saying this limit does not have a numeric value. That's all I'm saying here. As it approaches infinity. Okay? All right? Okay, so now I'm going to take the limit. Oh, who are you picking, Brady? Kyle. I figured you would. Okay? So I have the limit as x approaches what first, Kyle? Of what? ln of x. Okay? Where's that head? It's an exponent, right? It's to infinity. It grows really, really slow, but it is going to infinity, correct? Right? Because you're going to say, all right, e to what power is 100? E to what power is 1,000? You know, those powers are getting big. They're just not getting big very fast, but they are getting big, which is we're going to talk about today in BC Calc, because it has to deal with something called a harmonic series. And so this is going to infinity. So I'm going to take the limit. Okay, so now that means I'm going to take the limit as x goes to infinity of what? 1 over x, because that's the derivative of the natural log of x over 2x. So I'm going to write that as the limit. I don't know why I wrote it as that form. What does that simplify to? Well, no. Give it to me as I haven't taken the limit yet. No. Give me to as algebra. You're taking the limit too soon. Simplify this fraction. 1 over 2x squared. Now take the limit of that. I need an algebraic expression here. Okay? What is that going to become? Well, 1's going to stay 1, right? And where is this headed then? 0. It has a numerical value. 0 is a number. So as this function gets as x gets really, really big, this function is headed towards the x-axis, both as you go left and right. Does that make sense? Are we okay with that? All right. Who are you picking? Who? Josh. Okay. Notice it says negative infinity. That's to the left. Okay. So what am I going to do first? Yeah, take the limit as x approaches negative infinity of x squared. Where is that headed? Positive infinity, right? Okay. And I'm going to take the limit as x approaches negative infinity of e to the negative x. Pardon? Yeah, be infinity too. Because if you think about it, a negative 3 you could pick, right? Well, when I put a negative 3 in here, you're taking the negative of a negative 3. Well, that's a positive 3. The same thing would be a negative 100 would be a positive 100. Okay? So that means now I can take the limit as x approaches negative infinity of what?
2x over negative e to the negative x.
Okay, now, it's correct, right? Josh, do you notice anything? Okay, anybody want to help him out? What do you notice? Anybody? Cameron.
You bring e to the x to the top of it, but it's still going to be negative, so if you multiply two together, it's going to still be negative.
So let me ask you this. If I take the limit, am I headed towards a number?
No.
Why not? What's the problem? What's the problem if I put 100 in here? And then 1,000? And then 12,000? And then 3 million?
It gets bigger.
Right. So what I'm going to do is I'm going to see if I can apply L'Hopital's rule again. In other words, if I come up with an indiscriminate form, I can apply it and take the second derivative. And I can keep doing that as long as every single time I get an indiscriminate form. Yes, sir. Indeterminate form, by the way. Because I will not get one of those forms. I have to have a form that is in fractional form to apply the rule. Well, if I apply the rule, what will I get? Won't I won't know the answer, will I?
Can't you just move that e?
I'm not saying it. But what would be I gain from that?
You wouldn't need the rule.
My answer, my thing is that the answer isn't negative infinity.
That's just
Okay. What I'm saying is I want to keep it in this, and I want to apply the rule to see if there is an answer. That right now, if I say my answer is negative infinity or positive infinity, that's not going to be the correct answer. Yes, sir.
So how would we know like when to stop doing the rule?
When I do not have an indeterminate form.
So when you can't take the derivative.
Correct. So what I'm saying is, if I have this, what do I get? I get negative infinity in the numerator, correct? If I do this, what do I get? Yes, ma'am.
Happy birthday!
Yeah, they know.
It's alright.
Thank you.
Say it.
Yeah. Worst day of the year. Just a moment. What?
Do you have a bad birthday experience?
Oh, haven't I told you that? So my best was when I was 13, because I actually got cards from all my siblings, which was pretty cool because my sister was 20 and my older brother was 22. I mean, what do they care about a 13-year-old brat, right? And I was like really a brat, okay? My 14th birthday, we're sitting around the table, and we have lunch, and everybody, or supper, and everybody gets up and leaves. I go, oh, they're surprising me. So I sit there and wait. My mom starts cleaning up, and she looks at me, aren't you going to help me do the dishes? I said, yeah, anything happening today? She looked at me and said, why? I said, today's my birthday, and she goes, went to her wallet and gave me a $5 bill. Happy birthday. Anyway, we all make mistakes, right? So anyway, what's the answer to this? Negative infinity, right? Right? Would you agree?
Yeah.
So if I take a look at this, right here are my indeterminate forms, correct? is one of them negative infinity over negative infinity?
Yes.
It's this one. That's why I want to be in that form. Because now I can take the derivative again. And I can keep taking the derivative as long as I get one of these forms. But I have to demonstrate that I have one of those forms. So now what I'll get is I'm going to take the limit as x goes to negative infinity. Josh, if I take the derivative of this, what am I going to get? And if I take the derivative of this, what am I going to get? E to the negative x. Yes, ma'am.
If we keep like going on this, like we can keep taking the derivative as long as it's still in that form or whatever, why wouldn't we continue on like number 3? Because like you could have,
Because when I take the derivative of this, can I plug 0 in here and get a number?
yeah,
Can I plug 0 in here and get a number?
yeah.
It's not an indeterminate form, is it? It's not 0 over 0 or infinity over infinity, isn't it? It's a number over a number. So I can't apply it, and if I keep applying it, then I'm applying it in a way that it is not acceptable. I have to have it in an indeterminate form. And 1 over 3 is not an indeterminate form.
So it has to be an indeterminate form after you plug in the limit thing?
Correct. And then I have to show them separately. Okay? So now, if this goes to infinity, it's always going to remain 2, correct? So the limit of this is 2. Would everybody agree? Right? So because it's 2 and not 0 and not infinity, I cannot apply it again. So I actually have to figure out what this limit is. Well, if I put negative numbers into here, what's this limit, Josh? It's going to be 0, isn't it? Pardon? Because I'm putting in negative numbers, correct? And I'm making them positive, correct? And so this number is getting really big, correct? Was today Maroon Day and I didn't know it? Did you guys call each other up and say, hey, we're wearing the same sweatshirts?
They did actually.
Did you really?
Yeah.
And you wore the same? Did you do that? What happened? You got the wrong shirt. You got the right pants, Conway.
No, I'm matching with Jake.
Also,
Not even a joke.
there's also a bit of Green Day.
Yeah, it's got it. I dress it.
Oh,
Okay, is everybody with me on this? Have I answered your questions? Okay, so let's take a look at this. Is this in fractional form? Can I get it in fractional form? Okay, so I'm going to write it like this. The limit as x goes to infinity of the square root of x over e to the x, correct? And you can see this is headed towards infinity, right? And this is headed towards infinity, right? So I'm going to write that down, that when I take the limit as x approaches infinity of the square root of x, I get infinity. You have to write it down. You can look at it and see it, but you have to write it down. And I also have to write down that the limit as x approaches infinity of e to the x is also going to infinity. Pardon? Why?
I was just talking.
Okay. So I wasn't supposed to hear that.
Yeah, I just said it was 35. It's fine.
Oh, an attempt at humor. Thank you for sharing on my birthday.
You're welcome.
So, that means I'm going to take the limit as x goes to infinity Are we able to take that derivative in our head now? Carter, what is it?
1/2 x to the negative 1/2.
Correct. So when I bring it over, you're right. It's 1/2 x to the negative 1/2. What does that look like over here? 1 over 2 square root of x. Right? Okay. Then I'm going to take the derivative of that in my head. That's a nice one to do, isn't it? Are you okay with that now? Have you come to terms that you're starting to like e to the x when you take the derivative? What is it? And it's down here, isn't it? Because it's already in there, right? So this one from the numerator to the denominator. Does everybody see why? Do you see why this is in the denominator? See what this is in the denominator? So Carter, this will not be in, this is no longer an indeterminate form because there's a 1 up here. The limit of 1 is 1, isn't it? So what do I get as an answer here? 0. Because this is getting real big, isn't it? And you can do that on all of them. So if I would have something like this, and I know that was the last one, but on this, and I think this is the one that, right, that's the one I had you do, and you're kind of stuck for a bit, right, which was good, probably good to review, but we could have done L'Hopital's rule, right, because when I take the limit of this, I get 0. When I take the limit of that, I get 0, correct? And I would show that. And I'm going to skip it right now because I want to finish up. But then I could come back and say, all right, I'm going to take the limit of that. What's the derivative of this? What's the derivative of this? It is not in indeterminate form anymore, is it? What do I get? 4. Pardon? Pardon? Well, okay, let's do this. The limit as x approaches 2 of x squared minus 4. What is that? 0, isn't it? That's 0, isn't it?
Yeah.
And the limit as x approaches 2 of x minus 2, is that also 0? Will that give me 0 over 0? Is that one of my forms? Yes.
So, like if we're average like graphing, if we don't want to use this, if we do it this way, we can't really see the whole graph after.
Yeah, what this wouldn't show you is that a hole exists. You are right. When you factor, you realize there's a hole there or an asymptote. I mean, you still want to have those skills because those skills of factoring help you determine those things. This is just a way to find the limit, okay? And it's like, and I've seen people do this, okay? You really shouldn't use a screwdriver as a hammer, okay? It can be done, and I've seen my wife try to do that, okay? And with some type of nails, she's successful, okay? But really that isn't the purpose, you understand? L'Hopital's purpose is simply to find the limit if we have something that's in indeterminate form only. Does everybody understand that? It's just that case. Hannah.
Is it possible to use Hopital's rule if you have, like, let's say you have a negative infinity in the numerator and you have a positive denominator?
That's a great question. Is that one of my choices here? Then the answer is yes. It's got to be one of these right here. And that's why I said it's got to be one type of form of affinity over another form. What I'm saying by that is either they can be both positive or they can be both negative or they can be different signs, and you can apply it. Correct. You can't do it then, and because 0 is considered a constant, And it's got to, if it's some other constant, you can't use it either. You understand what I'm saying?
Yeah.
So it's got to be either 0 over 0 or in some positive or negative infinity over it, positive or negative infinity. Okay, does that help? Okay. I'm going to do one last one. I think this is the one that Megan did. Again, this was one I had to give a hint. Right, Megan? Because it's been a long time. Right? And that's where I had her do the conjugate. Correct? I could show that the limit of this is 0. Right? I would have to show that. Does everybody understand that? I'm not going to right now, but I would have to show that. I would have to show that is 0. Correct? But now I could take the derivative. What is the derivative of this? Well, that's going to be 0, isn't it? Right? This is going to be 1/2 x plus 1 to the negative 1/2 power. Would you agree? Excuse me, x plus 2. I said x plus 1. And this is what Carter was talking about. He was able to say, hey, this is what I'm going to get times, now I'm going to take the derivative of this. What's the derivative of that? 1. So this is the derivative of the numerator. This is the derivative of the denominator. Does everybody understand that? Now, it is no longer in indeterminate form because I got a constant here. Am I allowed to plug 2 in here? Do I get 1/4? Is that making better sense now? You see how it's a handy-dandy little tool? Okay? Alrighty.